Cambridge International Examination CIE IGCSE Physics. Today we get to look at questions on mass and weight. My name is Arnold Wagakromia and this is Kisembo Academy. So without wasting any more time, let's get to the first question. A cup contains hot liquid. Some of the liquid evaporates. Of course, if the liquid is evaporating, it means we know some particles have evaporated, they are out. What happened to the mass and what happened to the weight of the liquid in the cup? Of course, well, they are both going to decrease. When some of those particles in the liquid evaporate, it simply means that some matter has been lost. We know that liquid or water for that matter is a state of matter, and we also know that mass, is defined by saying that the amount of matter in a substance that is called mass. So if the amount of matter reduces, it means it's also going to affect the weight. So yeah, mass will reduce and the weight will reduce. The answer is A. So an astronaut in an orbiting spacecraft experiences a force due to gravity. This force is less than when she is on Earth. Compared with being on the Earth's surface, how do her mass and her weight change when she goes to the orbit? Now, one thing we should know is that mass is the quantity of matter in a substance. So the quantity of matter in a substance will always remain the same whether you are on Earth or whether you are outside the Earth. However, what is going to change when you leave the Earth is your weight, because your weight is dependent on the acceleration due to gravity. The acceleration due to gravity on the Earth is different from the acceleration due to gravity on another planet. So that is one thing you should keep at the back of your mind, that whereas your mass will remain constant, your weight will change because of the changes in the acceleration due to gravity. Looking at this, what's the mass in the orbit? Of course, the mass on the orbit will remain unchanged. However, the weight in the orbit, it will decrease. So the answer is C. So diagram 1 shows a piece of foam rubber that contains many pockets of air. Diagram 2 shows the same piece of foam rubber after it has been compressed so that its volume decreases. So yeah, its volume is going to decrease. What happens to the mass and to the weight of the foam rubber when it is compressed? So let's look at the mass. After you have compressed the mass, remember we said mass is the quantity of matter in a substance. So if I compress this foam rubber, is that going to change the quantity of the quantity of matter in the foam rubber? Of course not. So it's either C or D. Mass definitely does not increase. A and B are out. So it's either C or D. So let's look at the weight. Remember, weight depends, on gravity. The acceleration due to gravity is still the same. So, and also the mass has not changed. It is still the same. So the weight will also not change. So our answer is D. Next, weight is an example of which quantity? Weight is an example of, let me see, acceleration, nope. Force, yeah. Weight is a force. It's an example of a force because weight is actually force due to gravity. The mass of an object is measured on Earth. The mass is 5 kilograms. So that's the mass of an object. It's 5 kilograms. The object is then taken to another planet or taken to the moon. The mass of the object is measured on the moon. What is the mass of the object on the moon? We said that mass is the quantity of matter in an object. If the object has 10 kilograms, it's going to be the same 10 kilograms on another planet. So here it is unchanged. If the mass is 5 kilograms on Earth, it will be 5 kilograms on the moon. Which statement about mass or weight is correct? So here, mass is a force. Nope. Mass is not a force. Mass is the quantity of matter in a substance. Mass is measured in newtons. Nope. Mass is measured in kilograms, not in newtons. Weight is a force. Yes. Let's look at this one. Weight is measured in kilograms. Nope. Weight is measured in newtons. It is mass that is measured in kilograms. So The correct answer here is C. Next, what is the weight of an object? The weight of an object here, they say, is the force of gravity on the object. That sounds correct. Let's look at the rest. The gravitational potential energy of the object? No. The internal energy of the object? No. The mass of the object? No. The answer is A. The mass of the object is not the weight. The internal energy of an object does not tantamount to its weight. Next, which instrument is used to compare masses of objects? Here, when we are comparing masses of objects, we are going to use a balance. A barometer? Nope. This one is used to measure pressure. A manometer? Nope. A barometer is used to measure pressure. A manometer is used in the lab, still to conduct pressure experiments. A measuring cylinder is used to measure volume. So it's a balance that is used to compare masses of objects. A customer goes to a market and buys some rice. Yes, the storeholder pours rice into a dish that hangs from a spring balance, as you can see. He records the reading on the spring balance. Okay, that's the spring balance. This is the rice and the dish. So the customer then buys some pasta, and the storeholder notices that the reading on the spring balance with just pasta in the dish is the same as it was with rice in the dish. So they're saying that the rice and the pasta must have the same, of course, the pasta and the rice must be having the same weight. No, they do not have the same density. Remember, this spring balance here measures weight. So if it is measuring weight and you put the pasta here and the rice here and they are measuring, giving you the same reading, it means it's the same weight, so the answer is D. It can't be the same volume, it can't be the same temperature, it's weight. The mass of an astronaut is 70 kilograms on the moon. What is the mass of the astronaut on Earth? We said that mass will remain the same whether you are on the moon or on the Earth, so the answer here is still 70 kilograms. 11. The weight of an object is found using the balance shown in the diagram. The object is put in the left-hand pan and various weights are put in the right-hand pan. These are the results. This is our balance right here. Okay. So this is what is this thing here right there. It is what is here, the object. So when it tips down on the right hand side, this is the right hand side right here. If this thing is to tip down on the right hand, tip down like that, that is, if this is to do like that right there, this is what is on the pan, and we added this up on the pan too, and we found that it was 0.31. So meaning that when it tips like that, it means that the weights are heavier, they are 0.31 newtons. However, when we put the weights, these weights which are 0.27, this is going to tip slightly like that. It's going to tip slightly on the left hand side. So meaning that when we put 0.27, it's going to tip upwards slightly to the left like that. So in other words, you find that this is heavier than that. So now what I'm going to do is that I'm going to find the difference in weight. When I put 0.3 Newton weight, it tips like that towards the right. This is like the equilibrium position, the middle ground. When I put 0.3727 here, weights, it tips slightly upwards, towards the left. So I'm going to find this difference here. When I find the difference here, I divide it by 2. so that I see the magnitude of the weight between these two. So I'm going to go ahead and find 0.31 minus 0.27, and you'll find that in between here is 0.04. So this 0.04 newtons is between these two. That is what is lying between. That's the difference between these two. And maybe this 0.04 can be divided by 2 so that these two share it out. So when those two share it out, you'll find that 0.02 means that the upper part, this one, to reach the supposed equilibrium is going to become 0.02, and even the downer part will become 0.02. In order for this object for us to know the weight of this object, this thing should be balanced. It should be at the equilibrium. Since we have found the difference between these two and we divided it by 2 and apportioned the upper part and the lower part, so if this thing is to be here in the center, we can either say it is 0.27 plus that 0.02, and that will give us 0.29. Or we can say it is 0.31 minus this 0.02 because we want it to come up to that level. So it is this thing, since it's heavier, it is 0.31 minus 0.02. When we subtract the 2, we end up with 0.29. So you realize that this is just an estimate. It's not correct, like accurate, but it's an estimate. And from our objectives, you'll find that the best estimate is B, 0.29. Which is the unit for force and which is the unit for weight? Now, force and weight is the same thing. Weight is a force, but only that it is a special kind of force that is due to gravity. So it means that the unit for force and the unit for weight are the same. So the answer is D. So here, what quantity is measured in newtons? Of course, it says weight is what I mean. Pressure is measured in pascals. Energy is measured in joules. Density is measured in grams per cc or kilograms per meters cubed. So the answer is weight. Geologist places a small rock on the left-hand pan of the balance. This is the left-hand pan of the balance being talked about, okay? The two pans are level as shown when masses with a total weight of 23 newtons are placed on the right-hand pan. So when 23 newtons are 23 newtons are placed there, the thing is going to balance. So when 23 newtons are placed on the right-hand pan, the balance is on the same level. So take the weight of 1 kilogram to be 10 newtons. So they are telling us that if 1 kilogram is equivalent to 10 newtons, then they are asking what is the mass of the small rock. Of course, the mass of the small rock is equivalent to 23 newtons. So what is it in kilogram? We cross multiply, that is 10x, giving us 23 times 1, divide both sides by 10. When we divide both sides by 10, we end up with our value of x as 2.3 kilograms, and our answer is B. Please remember to share this video with your colleagues. My name is Arnold Rangakuramia, and this is Kisembo Academy.